Hi, my name is Grace, and today we're going to be taking a look at how you can do voltage or current pulses for PXI SMUs. So for certain devices like LEDs or MOSFETs or just other sensitive devices, sometimes supplying a constant DC source can cause the different electrical components to heat, so you might get different characteristics when you're testing your DUT, or it could potentially even damage some of those more sensitive DUTs. And so that's when you might look at using pulses to send short bursts of current or voltage. So let's go ahead and take a look at that today. So here in our system, I have an SMU that's connected to a high power LED that we're going to be sending some current pulses to. So let's go ahead and open up InstrumentStudio. InstrumentStudio is our companion software for PXI instruments, which provides out-of-the-box panels so that we can get started quickly. So I'm going to go ahead and go to a manual layout, and you'll see that it automatically detects all the different instruments that are in my system. Today, I'm going to be taking a look at our SMU that's in our slot 8 of our chassis and putting that on a large panel. So here you'll see that I already have my voltage and current measurements on my LED. So what I'm going to do is go ahead and go to our waveform mode, and this mode is going to allow you to do voltage, current sequences, or the pulsing that we talked about. So I'm going to go ahead and change this to pulse the current, and we'll set our pulse limit to 50 milliamps. And then the other thing that we're going to set to is changing our voltage limit range to 60 volts, since we'll be using a little bit more high power. So we'll change that. And then the last thing we'll set is our pulse limit at 35 volts. So this LED is high power, so it's going to get pretty light. So I came prepared. We're going to go ahead and put these on, and then let's go see if we have a pulse. We'll turn that on and press run. And you'll see that it's working quite well. So I'm going to pause this so it doesn't blind me. But you'll notice here on our graph that it's quite noisy. And so there's a couple different things that we can change in our settings to get a little bit better result. So if we go into our settings here, you'll notice all the different things that we can change. So earlier we changed the voltage limit range. And now we're going to take a look at the current level range. So right now it's set at 10 amps, which is just by default, but we can go ahead and change that to a couple different settings to see how that affects our noise. I'll go ahead and put these back on. We'll run that, go to our current level range, change it to 1, and you'll see that helps the noise a little bit. If we change it all the way to 100 milliamps, we're still getting the result we want, but with a lot less noise. And so that's just one way that you customize those current level ranges to get more accurate results. So in our system today, we use the 4139 SMU. One of the advantages of using pulsing is that you can reach outside the typical DC boundary. So let's take a look at a typical IV boundary for our 4139 to see what that looks like. So here on your graph, you'll see two different colors that represent the different boundaries. The darker teal represents the typical specifications and power boundaries when you're operating at a normal DC mode. So you can reach up to 60 volts, or you can reach up to the max amps at 3 amps. And then with pulsing, you can actually go outside those boundaries. So that's going to be this lighter teal area where you can reach up to 50 volts or 10 amps with the 4139 to get up to 500 watts of power. So this is just an example of one IV boundary that we have, but all of our SMUs have similar graphs that can show you the different ranges that you can use your instruments. So this is how we were able to quickly run pulses with our PXI SMU and InstrumentStudio. Thank you.